It's a discrete variable, 1 or 2 or 3. You can't make 3.2 baskets, right? And I'm going to go to table, and this is cool. Look in this right column. Ladies and gentlemen, that's the odds they make 0 baskets. Not very likely, is it? That's like 0%. That's the odds they make 1 basket, or 2 baskets, or 3 baskets, or 4. I'm going to keep scrolling. There's the odds they make 14 out of the 40. They're good free throw shooters, so isn't this unlikely that they hit these? Okay. Now the probabilities are getting smaller. There's the odds they make
10%.
exactly 30 out of 40. Okay? And Autumn, there's the odds they make exactly 31 out of 40. There's the odds that they make exactly 32 out of 40. 33 out of 40, and I'm stopping at what? 34. What did this do? This button is so rock and roll cool. What did this do? This just added up for us all those probabilities in that right column, up to 34. Isn't that cool? Hey, raise your hand, who knows this? Why does this have the highest probability right there? Someone knows this. Why is this, of all these, why is that the highest? Do you know our?
Mean.
Because that's the mean. Remember that? Remember the mean, what was expected? We would expect this person to make out of 40 attempts 30. That's why that's the highest. Now, Autumn, remember I was saying, you might not, I always warn students, because some students fall in love with this, and they go, cool. Then they're on a test, and I want to show you what they do. They go to this button, y equals. They go over here, and they forget to put that variable. So they put like a number like, let's say 35. Well, look what happens in table. So now they're freaking out. They're like, what's going on? So it's got to be a 1. If you want to use that y equals, what do you have to put for that last entry?
X.
Put an X.
So this is mostly a bell curve then.
That's right. It's bell curve. That was brilliant. And when the binomial distribution does become approximately normal if you have enough trials. We'll get to that later in the course. If it has a certain number of trials, it's got to be like a certain amount with a certain probability, it actually becomes bell curve. That's coming up in chapter 7. Cool, you see where we're going with this? Everyone we get into bell curves in chapter 7. All right. Hey, so if you want to use this, you can, but do you have to? No, and the only thing I get worried about as an instructor is that someone goes here, Randy, and they forget to put that X, right? I think it's awesome. I mean, I really do, but it's like, what if someone hits this y equals and they put this 35 here? We don't want this. Here, delete that. But if I put this X, is this cool? I can just go in here and add them up. Might take a while though, right? All right. Good job with that. Now, here's my next question. Hey, I bet you all want like a document that would list some of these common written statements for these buzzwords. Oh, you bet. Before you leave, you're going to get it. I just want to hand it out yet. All right? Make sure you have it. Here's my next one. At least. So what's the probability? He makes at, I have to put this in capital letters, at least, just like this, at least 35 baskets. And this is still out of 40 attempts, okay?
So that's a compliment, right?
Brilliant. It's the complement, I guess, of the last answer. But I want to play the role of a student on a test. Okay, at least 35. We're going to start by putting it in our own words, okay? At least means he makes 35, or he makes 36, or he makes 37, or he makes 38, or he makes 39, or he makes what? 40. Now, Evan, I'm sure you would have enough time on your test on Thursday to do this. You would just have to hit this button how many times? This would be the long way. What would you have to do? I'm sure you'd have enough time for this. You'd be like, okay, binom, PDF, 40 trials, 0.8, and I start with the 35, right? I calculate that on my calculator. I write it out to at least 3 decimal places, Autumn, right? And I have it. And then I go back to the calculator. I hit it again. But this time I type 40, comma, 0.8, and I hit a what? And I do this. And I continue this, Liz, over and over, and I take all of these numbers, and I just keep, let me get it in here, I keep adding these. Until I get all the way down to the what?
40.
To the 40. Now, could you do it that way? Absolutely. It might take you a few minutes. But can't we use that cumulative button? I mean, that cumulative button is there for a reason to help us. So we're going to use that. So I'm going to start out, this will be the short way, the fast way. And you know what's great about this, the benefit? This will keep all those digits of accuracy that we want. If I did it this way, I'd probably be rounding. And when you round, you get something called accumulated round-off error. You might round off your final answer by a few decimal places. You know, this will be exact. So what I'm going to do is I'm going to start out with this. It's going to be wrong, don't worry. I'm going to do cumulative. Everyone see the C? Binomial CDF, everyone can see this? Yeah? Good, Tori? Oh, good. 40, comma, 0.8. Now, and I'm just going to put that 34 we were talking about before. Now, tell me why this is wrong, if I did that in my test. This was the complete opposite, isn't it? This meant 35 and higher. This does, I'll put it in quotations, 0 successes through how many successes?
34.
0 through 34. But why am I writing this on the board then? I'm looking for 35 and higher. I got the complete opposite here. Because all probabilities of all events, if I sum the right column of that calculator that you just saw, they all have to add up to what? 1.0. Well, then why don't I just do that on my calculator and subtract it from 1.0? That's what I'll do. So I'll take this number right here. I'll say, what is 1 minus all of that?
I was already thinking about that.
Brilliant. That is really good. Seriously, Autumn. Because that is not easy. And there's the idea. I'm going to do 1 minus binomial CDF, and I'll get the exact answer. I'm going to have to do it this way, even though you could do it this way if you want on a test. But this will give me the exact answer.
But then, do you keep it 34 or we change it to? Yeah.
Great question. We don't want to be one off. Do you know why I kept this 34? So let's think about this. There was like 0 to 40, right? Here, look at this. 0, 34, 35, 36, 37, 38, 39, 40, right? There were all these. And you and I only want what part? We only want the part from at least 35 means 35 and higher, right? We just want to add up all those probabilities in the right column of that calculator. We're like, okay, we'll take 100% and we'll subtract out all those. But look at that number. Do you see it? 1 minus cumulative, that means accumulated up through
34.
the 34th.
So it is 34.
It is 34.
So we keep the 34 there. We don't put 35 there.
Exactly.
At least we're going to put 34. Or it's
And
gonna
can you
go
imagine,
less.
brilliant, and can you imagine me grading over all my years in statistics, how many times a student here put the number 35? You bet it's a common what? Error, but you've stumbled upon that. You're like, I'm going to be careful on that. In fact, remember how here I wrote for fewer, we wrote x minus 1? In your notes, you might write this. Someone see this? You might put this down right now. I'm going to erase this part right here. Binomial CDF. Oh, you can make a list. NPX minus 1. That was for the word fewer. When he said fewer than. And now, how about 1 minus binomial CDF? And we put n comma p comma x minus 1. That's very helpful for at least. Cool? And I have a document that I can hand out that you can use just for its guide. Now, I don't want this to be something you just memorize as a meaningless operation, like, I'm just going to memorize it. I think it's conceptual. Autumn, you conceptually understood what this button does. That's what I want you to do. This means accumulate from 0 successes up to that number. So if I needed at least 35, it's the complement to that. Man, very good. Hey, all right, I'm going to erase this.
So was our answer? William?
Oh, I apologize. Let me put that answer down there. I want probability that he made this with letter F. At least 35 baskets. It was 1 minus binomial CDF 40, comma, 0.8, comma,
34.
34. And the overall answer when we did this entire computation was
0.161.
161. There's a 16% chance this person will make at least 35 of the baskets. And he's expected to make 32, right? But there's a 16% he can make that or higher. Remember that flipping the coin thing? It's like, oh my God, there's a 1% chance that could happen. I saw it happen. Could the person go 40 for 40? Well, very unlikely, and we can look at the odds, right? We can look at those odds. But that's what's interesting. Does anybody know Steph Curry? Like I heard a story about Steph Curry, not from the free throw line, but from 3-point range. I heard he hit in practice like shooting around like over 70 in a row.
Wow.
And it's been like documented. I mean, they might have video tape on this stuff. So, ooh, Autumn, go ahead.
For D, E, and F, are they always gonna have like the same number? Like for this one, it's all 35 baskets. But it just
The
different
textbooks
things.
seem to do that. It's not guaranteed, but I noticed like a great problem in the practice Autumn out of the textbook, I have it on the practice document for everyone, is in section 6.2, there was a problem with American Airlines.
Number
And it was
35.
on-time flights. And it was number 35. But if you're just curious, by your question here, Autumn, they kept using 10. There was a total of 15 trials of flights, and they go, and letter B, exactly 10. And letter C, they go, fewer than 10. They don't have to, but they seem to do that if that helps you.
Are you
They seem to
doing
do it.
this?
Probably not.
Okay. That's nice.
Autumn will be like, you should have kept these this way. And when there's only one more keyword, it's the word between. So I'm going to make this letter G. And we've covered everything. What is the probability that he makes between 31 and 35 baskets? Now this is going to be interesting because some people in this room will say, well, I'll just do this on my own.
So would the keyword in this one be and?
No, it's the word between. So let me put that in capital letters. And it's our last key word for these binomial experiments, Mia. We've had exactly, fewer, or fewer than, we'll just look for fewer, at least, and then this last one is when they're asking about between. Now I want to point out, Mia, if they don't use the word inclusive, will you assume they mean inclusive? So when they said between 31 and 35 baskets, we put that in our own words. We're saying inclusively, include the 31 and the 35. So that means they make either 31 baskets or 32 baskets or 33, all the possibilities between those. So they make 31 or 32 or 33 or 34 or 35.
So cumulative 31 to 35?
That's it. Cumulative 31 to 35. Now, I have a feeling, like during a test, people get worried about trying to use the shortcut here. So they just do this the long way, and there's nothing wrong with that. Everyone, there's nothing wrong with that. They're just like, I'll do this the long way. They go back to this button for exactly, binomial PDF, right? Which is doing this. And they just keep computing for what? They go binomial PDF. And it's, 40 successes, 80% success rate, right? And then 31. They write it down. True? Out to a bunch of decimal places, right, Autumn? And then, they got another one coming. When I see a hand up, I'll be right there. Julie, I'll be right there. I'm going to put 32. This is the long way, but boy, won't this work? Yeah, add up all these probabilities, and where do I got to stop?
35.
I got two more. So there's a button called second enter on your calculator. It allows you to reproduce stuff, and you might find this not too bad. And when I'm abbreviating that PDF, there was a P. Ready? 4. And then lastly, take this one, add this one, add this one, and there's one more. What would I add? PDF 40, comma, 0.8, comma what? 35. Cool? Oh, Julie, go ahead.
Instead of having to calculate like each and every one and then adding, then she just go to the y equals and just add
Brilliant. That was brilliant. Did everyone hear her comment? I want to repeat this. Everyone hears this. She goes, and I love how you say, couldn't you? She's like, hey, professor, couldn't you? You showed us how to go in that column. You know, if you remember to put the variable. She goes, couldn't you go in there and just get that screen open, look between the 31 and the 35, and add up all the numbers in the right column between 31 and 35? Absolutely. I think it's awesome. I think it's a great way. Just remember to put that X, right? I love it. And this is another way. And both of those are outstanding. I love it. And I would encourage you to all, when we're talking about rounding, everyone when we're talking about the 3 decimal places, write those out, probably more decimal places, and then that final one, once you add them all up, you can round that to 3 decimal places. Sound good? That works perfectly. Cool? I want to just show you the rock and roll way, the fastest way. Sound good? Yeah. With the C, the cumulative. And you're going to help me build this formula for this. How could we use the cumulative button? I'll start out, you can tell me if it's right or wrong. So when I'm going to do this a faster way, I'm going to use this button with the C. Right? So, is there a way to do this faster? All right. Watch when I do this. Some of you might go, that wasn't so great. All right, here we go. I'm going to start out. This is a fast way to compute this. Here we go. Binomial CDF 40, comma, 0.8, comma, what was this upper number? 35. Now, is that the right answer?
No.
Good. You're like, is it too little or too much? In terms of answering this question. This was a probability question. You get a result that's, some number less than 100%.